Now we're going to talk about drawing conclusion based on facts. So the definition of deductive reasoning, the process of reasoning logically from given statements or facts to a conclusion. When you're given true statements, you can use deductive reasoning to make a valid conclusion. We're going to use two laws to use deductive reasoning. The first one is the law of detachment. In the law of detachment, if the hypothesis of a true conditional is true, then the conclusion is true. And in symbols it looks like this. If P, then Q is true. And again, I'm using my mouse to write, so bear with me. If P then Q, if it is true, and P is true, then Q is true. Sometimes it's easier to not look at all the words and look just at, recognize them as P's and Q's. Let's look at this and see. For an example, if there is lightning, then it is not safe to be out in the open. Marla sees lightning from the soccer field. In our conditional, there is lightning is our P, our hypothesis. It is not safe to be out in the open is our Q, the conclusion. Together, it's a true statement. If there is lightning, then it is not safe to be out in the open. So our next statement says Marla sees lightning from the soccer field. So that goes with P. Marla sees lightning from the soccer field is true. Then we have to be able to conclude that Marla is not safe out in the open. That means Q is true. We just relate it to our new statement. It's going to take some practice to get comfortable with the law of detachment and the law of syllogism. We'll do more practice in the classroom. For the law of syllogism, this law allows you to state a conclusion from two conditional statements when the conclusion of one statement is the hypothesis of the other. That's important to get. When the conclusion of one statement is the hypothesis of the other statement. So look at our example. If a number is divisible by 12, then it's divisible by 6. Notice our hypothesis. A number is divisible by 12. In our conclusion, it is divisible by 6. Well, in the second statement, a number is, and this is a true statement, if a number is divisible by 12, then it is divisible by 6. And our second statement, if a number is divisible by 6, then it is divisible by 3. That is also a true statement. Well, in the second statement, our hypothesis, a number is divisible by 6, is actually the same as our conclusion in our first statement. So that's the important thing we want to make note of. So in our conclusion, we can now state that if a number is divisible by 12, then it is divisible by 3. And in symbols, it looks like this. If P then Q is true, and Q then R, and I'm going to put that little tail on there to make that look more like a Q. Q then R is true. R just being the conclusion of the second statement. So this was P, this was Q, and it was true. This turns out to be Q still, if you can read that. That makes it as divisible by 3, the R. Then P then R is true. So this kind of goes with the transitive property in algebra. So I gave another example here. If a figure is a square, then the figure is a parallelogram. Well, our P is a figure is a square. Our Q is the figure is a parallelogram. Then in our second conditional statement, if a figure is a rectangle, well, this isn't the same as our Q. So we really don't have to go any further. What we can conclude is that there is no conclusion because it does not meet our law of syllogism that says if P then Q is true and Q then R is true, then if P then R is true. So there is no conclusion for this second example. We will practice this in the classroom and hopefully make you very comfortable with the law of detachment and the law of syllogism.